today the percent topic we're going to talk about is finding percents again, like we did yesterday, but we're really interested in this thing called part to whole ratios. Part to whole ratios. You hear it when I was little, they used to have this commercial for a type of gum. I think it was Trident, Trident gum. Mm-hmm. And they used to have commercials on TV. We didn't have the cable like you guys do. And the big commercial was 4 out of 5 dentists recommend Trident gum. That was like their big thing because it didn't stick to your braces, right? And so that's kind of a ratio. And they do that in commercials. If you listen into commercials, you'll hear that a lot more. That was one of the only ones I remember because there weren't so many commercials in TV things. You didn't have a lot of choices. So that's a part to whole comparison. So a part to whole comparison is where you know part of something and then all of something. Like in our classroom, if we count it, the boys and girls, let's see, there's 1, 2, 3, 4, 5, 6 girls in class today. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 boys. Okay, so in our classroom, we had 6 girls. Oh, did I count wrong?
Yeah.
Thank you. So 7 girls and 13 boys. So there's different types of ratios. There's part to part. So a part to part comparison would be 7 to 13. Part of the class being girls and part of the class being boys. Part to whole comparison would be 7 girls to 20 what? Kids or students, right? 20 students. Or I could do 13 boys to 20 students. So do you see the difference between part to part and part to whole? Who could put it in their own words? What's one of the big differences? Or how can you train yourself to remember the difference? Yes, Samantha?
It's like part to whole, it's like a part of the whole thing, and then you like fragment.
How do we get the number 20?
How many there are?
How many?
The whole.
Total. It's a total of all of the students instead of just the types. So Andy, how do we get the 20?
By adding 7 girls to 13 boys.
Right, so what's the whole? Okay, and in the problem, what is the whole? The boys, the girls, or the students? Right, and what's one of the parts, Nick?
Girls.
Girls, right? And the other part, Emma?
Boys.
Boys, okay. So that's what we're going to focus on for a few minutes. And then I'll give you some problems to practice, and we'll have a little time to start and finish up tomorrow. Okay, I may send you home with part of the packet. So in this problem, it says, let's make this bigger. Can you read that? In a PE class, 16 students were practicing long jump, so that's one thing that's going on. 9 students, that says were, practicing high jump. Let's move that over. Sorry, or maybe just I need to go smaller. There. And then there's what percent of students were practicing the long jump? So you're going to use a ratio table. This is called the ratio table method. So you make a chart, just draw a line, doesn't have to be fancy. And you're going to write in there the parts and the whole. So what's one of the parts, Claire? Okay, long jump, right? But you're right, it's 16. What's another part? Yeah, Isabella? So there's the high jump, there's 9 students, and so what's the whole, Mark?
The whole is
Help them out, Andy.
25.
25, and what does that 25 represent? 25 what, Mark?
students.
25 students, right? The total, right? The total. Okay, so the ratio table method is basically having you take your parts and add them together to get a whole. That's the first part. And then you have to figure out a percent. So Mark, what percent are we trying to figure out? What's the problem about?
How many percent is the long jump?
Right. Well, in this problem, it's just asking what percent we're practicing the long jump. And then you can figure out the high jump, right?
Yeah.
Percent is per 100, right? Right now we have long jump. Oops. We have long jump right here per 25. We have long jump per 25. But we want to make it per 100. Okay, so there's a really easy strategy that we can do. We can just make that, yes.
Is it seeing how many times 25 goes into 100?
Perfect, right. That's what it's just the fraction work from chapter 4. 25 goes into 100 how many times?
4.
4. So you just multiply by 4 here,
Oh,
and then you multiply by 4 here. Really, really perceptive. Good job. 16 times 4. Well, what's 10 times 4? 40. And what's 6 times 4?
24.
So 40 and 24 make 64. So that's your answer. It's 64 out of 100. 64%.
Oh, that's really easy.
It's a nice smooth method. Okay? And so we could just write the answer down here, 64% of what? Students were long jumpers. What's the question? Okay, so can we answer Mark's question? Can you figure out, Mark, what percent of the students were high jumpers?
46.
What'd you do? 46? That adds up to more than 100.
36.
Right, you're taking 100 and you're subtracting 64, right? Or you could just take 9 and times by 4. Okay, so the answer to the question is 64, but we could answer other questions too.
Okay.
Michaela.
What if it's a number, like the student total? What if it's a number that can't go into 100?
Yeah, then we do other strategies. But the reason we start with a strategy like this is a real common sense strategy. And when it gets really complicated, you actually start using calculators. But in 6th grade, so that's another great question. In 6th grade, we're really focusing on common sense numbers first. So the other strategies so you have enough common sense that when you start using the calculator, you can tell if your answer is reasonable.
Okay.
So here's another problem. Let's have somebody read that for me. Jackson.
In art, 7 students were painting and 13 students were sketching. What percent of students were sketching?
Okay, so is this problem similar? Yeah, we could use a ratio table. So Haley, how would you, Haley Harlan, what are your parts? Yeah, painting and sketching. And then the bottom down here, Mark, what's the bottom going to be this time? Total students. Okay. So, Haley O, what number should I put in some of these columns? Start me off. Okay, 7, perfect. 7 students were painting, 13 students were sketching. So Andrew, what goes down here? 20. So Sarah, how are you going to help me get to percents? What do I need here?
I need,
Because I want to have right now, the question is, what percent of the students were sketching? And I have 13 per 20, right? But I want percent, so I need to have per 100. Can you think of a way to get 100? Like, what do I have to do to 20? By 5, right? So if I times by 5, I get 100. So I can times both of these by 5.
Well, if it's bigger than, like, if the total number is bigger than 100, do you divide?
You would have to go down. There's all kinds of strategies. Again, we're going to stay with the kind of basics today.
so you always go to percentage of 100.
So this is 35, right? What's 13 times 5? 65, right? So Andy, what's the answer to the question?
65% and 100
65% of,
students.
yeah, of the students. You would just say of the students. We're sketching. Oh, it's Wednesday, huh? Okay, so this is what I want you guys to do. I'm going to adjust the board. We're going to go one more day of no homework.